Hello everyone. Support vector machine. SVM is a supervised machine learning algorithm that is used for classification and regression problems. It can solve linear and nonlinear problems and works well for many practical issues. And the basic idea behind the algorithm is that it creates a line or a hyperplane, separates our data into categories, and the basic applications of SVM are image recognition, face detection, voice detection, etc. So, to understand the SVM algorithm, one needs to be first familiar with three important terms that are hyperplane, support vectors, and margin. So, hyperplane is basically a decision boundary that divides our dataset, and basically, SVM can generate many hyperplane, but to decide the best hyperplane, it is the one whose distance to the nearest element of each element is the largest. By that I mean, okay, so basically, firstly, the data points that are nearest to the hyperplane or the decision boundary is known as support vector. Here, these two are the support vectors, and the distance between the support vector is known as margin. So, our the hyperplane that is best for our data set is the one where the margin is highest, where the distance between the support vector is the largest. Okay, so moving further, we have two types of SVM. We have linear SVM as well as non-linear SVM. So for linear data, the hyperplane is just a straight line because here you can easily segregate the data set into categories. But for non-linear data set, when it's clear that there is not a linear decision boundary, here you cannot segregate the data with the help of a single line. So here we add a third dimension. Up till now we had x and y. We create a new dimension, z dimension now. That helps us to segregate this type of data. As you can see here, we have a blue plane in z dimension that segregates our two different data. So here we have linear and non-linear SVM, and moving further, so basically we found a way to classify a non-linear data by mapping it to a higher dimension. But calculating this transformation can get pretty computationally expensive. So basically SVM algorithm has a technique called the kernel trick. The SVM kernel basically is a function that takes low dimensional input space and transform it to a higher dimensional space. That is, basically it converts non-separable dataset into a separable dataset. So in SVM we have three types of kernel. First is linear kernel, then polynomial, and then radial basis function, that is RBF kernel. So as the name suggests, linear kernel linearly separates the classes, and the polynomial kernel is used to create decision boundaries in non-linear dataset, and the RBF kernel is basically the widely used kernel in SVM algorithm. It basically converts highly non-linear features to into a linear space. So after understanding the hyperplane support vector margin and the linear non-linear SVM and the kernels, we move to the further last part, that is implementation. So in implementation, first we import the SVM function from the sklearn library, and after that here we have taken a data set, created a data set, uh, the purple dots and the yellow dots, and we need to segregate those dots. We need to create a hyperplane. So here we have taken all the three kernels, or we will compare the outputs of all the three kernels. So after declaring the model of our SVM classifier, we fit the our dataset into that model, and moving further, we had as an output we had these three plots for linear kernel, polynomial kernel, and RBF kernel. In linear kernel, as you can see, there is no such hyperplane that can clearly segregate our two different types of dots. And moving further to polynomial kernel, as you can see, it's better than linear kernel, but it is not that appropriate for segregating the two data sets. Last, when we come to RBF kernel, you can see a hyperplane that can clearly segregate the red dots from the blue dots. So as you can see here, for our example, RBF kernel worked best. So this was all about the SVM algorithm. That's it. Thank you.